Linear systems. So let's assume that they give us the equations of two lines and they ask us to find the point of intersection, or sometimes when they say solve these linear systems of equation, essentially what they're asking us is to find the point of intersection between these two lines. So there are different methods for solving this. One of them is by graphing each of these lines, and then once you graph them you can see the point where each of these two lines meet. So here we have a graph of each of the lines, right? Y equals 2x plus 1 and y equals x minus 1, and we can see that the point of intersection is this one right here, and it happens to be, for this example, it happens to be the point -2, -3. So let's write it down here, -2, -3. Alright, so this is the only point that these two lines share. Any other point belongs to that each of the lines respectively, right? And of course it's represented with the x, y coordinates, right? So this is the only point that these two lines meet. So that's one method, basically by graphing. Now the other method, and more commonly, they may ask us to find the point of intersection of these two lines without graphing them. So how do we do this algebraically? Well, let's look at this example. Let's do it algebraically. So the first thing, when you're given the two lines, the first thing I suggest is to label each of these equations as 1 and equation 2, right? It doesn't matter which one you label 1 or 2. Let's just label them in order to keep order. And the next thing that we do is this. So we know that x and y is the only point. There's one point with xy coordinates that these two lines share, right? That means they'll have the same x coordinate, the same y coordinate. Well, since each of these lines is in slope intercept form, we know that they share the y coordinates, so we can set equation 1 equals to equation 2 and then solve for x. Right? So let's write this down. So the first step would be let equation 1 equals to equation 2. And let me just write equation. Let equation 1 equals to equation 2 and solve for x. Right, so let's do that right now. So what we do is we write equation 1, which is 2x plus 1 equals to x minus 1. Now let's solve for x. So let's move all the x values to one side of the equal sign. All the expressions that have as an x variable. So x to the other side becomes negative x. This plus 1, when we move it to the other side, it becomes -1. And this -1 stays there. Alright, so 2x minus x gives us 1x. Right, gives us 1x. And -1 gives us -2. So our x value here is x equals -2. Now that we found our x coordinate, right, we can use this x coordinate to find our y coordinate. So take this and substitute it into either equation 1 or equation 2. It doesn't matter. Substitute it into one of these equations to find the y coordinate. So let's do that right now. And I'm gonna substitute it into equation 2 since it seems to be simpler. So the next step is to substitute x equals -2 into equation 2. Right? You can also put it into equation 1 and we should get the same answer. So let's do that. Equation 2 happens to be y equals x minus 1, but now we're gonna instead of x, we're gonna write -2. Let's just leave it in brackets for now. -1. Right, so this is x minus 1, which was equation 2 before, right? X minus 1. And now, what is the y value here? Y is going to become, well, -2 minus 2 minus 1 becomes -3. Alright, so we have these two coordinates here. We have our x coordinate and our y coordinate. So we can say that therefore, right, the point of intersection is, and we can say it's -2, -3. Right, so the point of intersection between these two lines, it's going to be -2, -3. And this, of course, matches what we expected to see, right? Graphically, we also noticed that the point of intersection was -2, -3, and here we just demonstrated this algebraically.